I'm Rosário Domingues, professor at the University of Aveiro in Portugal, and I work with lipids, focusing on the analysis and identification of lipids in different biological samples, including food. Lipids, usually called fats, include fatty acids as well as other biomolecules behind what we see on a nutritional level. Typically, nutritional levels include lipids that contribute to caloric intake, such as saturated, unsaturated, and trans fat. Nutritional levels also generally list cholesterol, a sterol lipid. But behind what is seen on a nutritional level, our food contains several thousand of lipids, including fat-soluble vitamins, sterols, waxes, phospholipids, and glycolipids. For example, the Foodomics database of the Periodic Table of Food Initiative, or PTFI, lists over 3,000 unique lipid components. That is an incredible diversity of biomolecules that we typically think of as fat. Why do we have interest in lipids? Because lipids are in all food, and these are important molecules in our daily life to keep a healthy body. Lipids provide a dense form of energy, fueling our activities. They are also key components of cell membrane structure, enabling cellular communication, nutrient transport, and cellular waste removal. Additionally, some lipids are precursors to hormones that are essential in metabolism, stress response, and various physiological processes. Foods can contain well-known fatty acids such as the important omega-3 fatty acids, some sterols like phytosterols that are also very important in helping to regulate cholesterol, but also vitamins like vitamin A, D, E, and K. Most people don't recognize that they are lipids. The discovery of lipids is an exciting frontier of science, with evidence suggesting that many lipids are still unknown, contributing to the dark matter of food and our diets. We don't know what all the lipids are in food, and we don't know all their functions in our body. Our lack of knowledge on lipids is directly linked to the limitation we had with regard to robust and sensitive methodology to identify and quantify these molecules. Advances in omics technology are enabling analytical solutions for identifying the diverse array of lipids in food. This is the field of lipidomics. So, what exactly is lipidomics? We know that Foodomics is the application of omics technology applied to comprehensively profile the components in food. Likewise, lipidomics is the application of omics for the comprehensive study of a diversified molecular species of lipids. The overall goal of lipidomics are to identify and quantify, examine their cellular and tissue distribution, both in food and humans, and understand the implication of consuming lipids on our metabolic pathways and our health. Thus, when we look at the food label, we know the total amount of fat, and there is typically information of some fatty acids like saturated fat and the total amount of cholesterol, which is also lipid. But there is a lot of information missing, considering the huge amount of different lipid classes and different lipid molecules that exist in food. So the full lipidome remains largely unexplored. And if we don't know what we are eating, we don't really know the true nutritional value or potential health benefits of food. Current research mapping the lipidome of foods provides evidence that food's lipidome is a specific lipid signature or fingerprinting. This lipid fingerprint distinguishes the food and can vary substantially across different species and varieties, and across similar food raised in different environments or using different growing practice. So we can then use this fingerprinting to evaluate the quality of food that we are eating. This can also help with determining the authenticity and be used as a tool for traceability and food safety, and to test for adulterations, such as the addition of vegetable oils or chlorophylls to olive oil, or the presence of contaminants such as bacteria in bivalves or eggs, which can be harmful to health. A deeper understanding of food lipids can provide scientific evidence linking lipid composition to health, helping to define healthier diet, and also to identify harmful foods that raise chronic disease risk like obesity or cardiovascular disease, and explore bioactive lipids with benefits like with anti-inflammatory properties. In addition to the health impact of food, we also need to be concerned with their impact on the environment for future generations. So we need to fight climate change. We need to have more conscious attitudes about sustainable food production and also using sustainable sources of ingredients. Our laboratory in Portugal is near the sea, and we have a tradition of consuming algae. We have looked into the lipid composition of these marine vegetables because algae are a sustainable source of nutrition and healthy lipids. We can collect them from the sea, but they can also be produced in aquaculture in a more sustainable way. And we are very lucky because here near our university we have producers of algae such as uva, commonly known as sea lettuce, porphyra, widely recognized as northern sushi, codium, with a unique spongy texture that is often used in salad soup, and palmaria, known as dulce, often used in salads, snacks, and as flavor enhancer in various dishes. These are typical edible seaweeds that we can eat in our food. We eat these algae when we go to eat sushi or other dishes in Japanese, Korean, or Chinese restaurants. In many parts of the world, algae is not widely consumed, but in Asian countries, algae and other sea vegetables have been consumed for a long time, and they have been associated with health benefits, like lower incidence of cancer, lower incidence of obesity, and lower incidence of cardiovascular diseases. That's why algae, not only macroalgae but also microalgae like spirulina and chlorella, are increasingly becoming popular around the world, not only for food but also for food supplements or novel food ingredients. And there are increasingly recommendations that advise their use for health and sustainable diets. For example, World Health Organization dietary guidelines provide recommendations that promote the consumption of diverse and nutritious food, including algae as a source of essential nutrients. And EU initiatives such as EU Green Deal and Farm to Fork promotes the algae and other plants in our diet. The lipidome of algae is quite interesting and diverse. Algae have lipids in their membranes that have high amount of omega-3 fatty acids like alpha-linolenic acid or docosahexaenoic acid, more commonly referred to as DHA. And the lipids found in algae have well-known beneficial effects to prevent non-communicable diseases like cardiovascular disease, inflammation, and disorders related to mental health. Many people hear omega-3 fatty acids and they think of fish. Well, where do you think the fish got the omega-3 from? They get them from the algae. So, with concerns of overfishing and the cost of incorporating seafood in the diet, algae can be a potential solution to increase intake of these important lipids. In addition to being a sustainable source of omega-3 fatty acids, our research indicates that algae also contain lipids with important bioactive properties. Some of them have anti-inflammatory activities, antimicrobial, antioxidant, or anti-proliferative, anti-tumoral activities, that can be explored as potential therapeutics or pharmaceuticals. Here you can see a diagram that shows the number of unique and common polar lipid species, which some have important bioactive properties and that have been identified across these 6 species of seaweeds. Only 35 of the 477 different lipid species that were identified were common to all 6 species of farm red, green, and brown seaweeds. These reinforce the potential of exploring the full lipidome of algae to further understand how it can play an important role as a functional food for health promotion. So, we know that mapping out the lipidome will be very important for identifying lipids in algae with potential health benefits, and understanding the variability in lipid content in algae produced from aquaculture or from different countries. There are many other foods that are underutilized for advancing human and planetary health, and lipidomics can be an effective tool for illuminating the nutritional properties of foods around the world, which varies in its impact. Food lipids have an important role to play in this effort for a better world, and lipidomics will boost innovation to find solutions for healthy, safe, and affordable food for all.